Welcome. Thanks for coming today. My name is Henrik Johansson. I'm a security solution architect with AWS. With me, I have somewhere there, my co-presenter, Kapil Thanjavelu. He's a technical fellow at Capital One. He's going to join me later in the session. So welcome to Protecting Your Data in AWS. We are going to have a QA in the end if we have time. If we don't have time, we're still going to be around afterwards outside. So feel free to come by and ask any question. Reminder, in the end, please fill out the survey. We'd love to get your feedback and anything good or bad that you think about it. So make sure you fill that out. A little bit on what to expect from this session. Hopefully not me falling down here. We want to understand how or what option you have for protecting your data using encryption on AWS and AWS services. Also look a little bit on how to secure your data on Amazon S3 using various policies and various techniques. Looking a little bit on that database platform security. Excuse me. And a quick note on how to automatically validate and audit your data and your data protection policies. And that's actually going to plug into what Kapil is going to talk about and hear from Capital One on how they do data protection and reactive response on unauthorized changes and configuration creeps, things like that. So jumping straight in on transport security. How you, and this is really important, we get these questions a little bit, how you authenticate AWS to you and also protecting your confidentiality using TLS in transit. So it's important to know that TLS can be used on any AWS APIs to protect the data, both when you upload and download and make configuration changes. So any API that you use, you can use TLS with. There was a talk earlier today, I believe. So if you didn't attend it, go back and take a look at it. That describes a little bit on how to use SIG-v4 for authentication and management against your services as well. Also important to know that you can provide your own certificates to be presented to your customers when you're using, for example, Elastic Load Balancing or Amazon CloudFront. So CloudFront is a content distribution network, so CDN. You can also present your own certificate when you use regular EC2 services that are published independently, but of course from availability perspective, we recommend that you load balance these services or use a CDN network. Not sure if everyone knows, how many people, and I do like to do some polling, how many people have started looking at ACM or know that we have ACM launched? A couple of people, awesome. So ACM is AWS Certificate Manager, which is a way to provision trusted SSL and most like TLS certificates from AWS to use with services running on AWS using Elastic Load Balancer or Amazon CloudFront distributions. And the main benefit that you will get from this is that we will handle all the muck. We will handle the key pair management, we'll handle the CSR generation. We can handle the renewal of the certificate automatically, so you don't have to replace certificates on your resources. You don't have to renew the certificate. That will be done automatically by us. We will also do the deployment to the resources, so the CloudFront distributions or the Elastic Load Balancers. The way you can do this is through either the console, or if you prefer to, you can use command line interface, or using the APIs available as well. So whatever you need to integrate with your tooling, you can easily do it, or if you prefer a manual usage using the console, absolutely go ahead. The way we handle the validation is through email. So we use regular domain validation. We will look up using a whois and look up the registered email technical contact for the domain. Or we will also send out through a couple of predefined administrative emails that are commonly used for email validation. And these are described centrally by policy, so it's nothing. We follow the same standard as everyone else on this. A couple of important things to know about the ACM-provided certificates is that you can use both single domain name, so for example, www.example.com, or you can use a wildcard domain as well. Wildcard domains are very popular when you have multiple subsites and subdomains that you want to provide using a single interface. You can also use a combination of this in the same certificate, and you can actually have up to 10 certificates or 10 domain names in the same certificates. Also, as I mentioned earlier, the ACM-provided certificates are managed. So we handle the management of the private key for them. We also protect and manage that private key. Important to know that the ACM certificates cannot leave the service, so you can't use them directly on an EC2 server. So if you do have a need for a publicly approved and validated certificate on the EC2 server directly, you will have to use a different method or a different certificate provider to generate those certificates, or if you run your own PKI infrastructure. It does integrate directly with, as I mentioned, ELB and CloudFront. Also important on the algorithm, we do use RSA 2048 certificates and SHA-256 encryption. And really important, it's free. So it's a really good pricing option. We do charge for the services, of course, running on them, so the ELB, but the certificates themselves are free to issue. The next thing I want to mention, I don't know, again, has anyone looked at S2N? Very few hands. So S2N is an open source library, the project that we provide, which is called Signal to Noise. It's essentially a TLS library that we have designed ourselves to help developers who want to implement transport security using TLS. The key benefit here is that it's a very small library. It's about 6,000 lines of code. We have stripped off a lot of the extra and rarely used features of the TLS options that developers and services really don't use, and that just to get down to really fast, small protocol with a lot reduced attack surface. So if you're interested in it for your developers, check it out. It's on GitHub under AWS Labs and S2N. Moving to the big area, which is data security at rest. So looking quickly on how data at rest encryption works, you have hardware and software that issue a symmetric data key. That symmetric data key is combined with the plaintext data that you want to encrypt, generating some encrypted data. That encrypted data is then stored onto some sort of storage in encrypted format. You then have the symmetric data key that you match together with the master key to create basically an encrypted data key, and then store that encrypted data key together with the object in the storage. And this also generates a key hierarchy that you need to maintain and understand. And these are some of the challenges with running your own crypto if you want to build your own crypto library, or if you want to build your own crypto management. So a couple of key questions, pardon the pun. So you need to think about where these keys are stored. Are they stored on hardware you own yourself? Are they stored in a cloud provider? Where are they used? So for example, do you write your own client softwares and store the keys in there and use the keys through your software? Or do you just use them on server software, for example, in a cloud provider? And who can use them? And this is probably the biggest challenge for a lot of people is who can use your keys and how can you prevent access and restrict access to your keys? And especially, how can you restrict what operations you can do with those keys? Again, user and applications that have permissions to the keys to use them, or also cloud provider applications that give permission. And this also includes how do I restrict who has administrative access to my key and what they can do. And again, think about what assurances do you have for proper security around these keys. So a couple of options when using encryption on AWS. We have two different main methods. One is client-side encryption, where you encrypt the data before you submit it to the service. So you can either encrypt it on your side and just submit it up there, or you can supply encryption keys or regular keys to the AWS account and have it encrypted before it gets stored, but still on the client side and client-managed keys. Or you can use one of our clients that we have available in client libraries. So for example, for Amazon S3, EMR, and DynamoDB, and I believe there's a new Java client library as well available now. You can also use server-side encryption, but still use client-side keys. So when you use server-side encryption, the data is encrypted after it's received by the service. And we have a number of integrated services that support this. So for example, S3, Amazon Elastic Block Storage, or EBS, RDS, etc. Redshift, definitely one of the bigger ones here. And the important thing here is to combine what we mentioned earlier, that the endpoint is still going to be TLS encrypted. So you will still have encryption in transit, even though you encrypt it on the server side. So one example on client-side encryption in AWS. So in this example, we're going to look at using S3 and EMRFS together with DynamoDB to do client-side encryption using the AWS SDKs. So in this case, we have an on-prem solution where you have your own applications in your own data center that basically has all the data that you want to encrypt and then store. You have to provide the key management infrastructure and the encryption client application and manage the secure access between the application itself and the key infrastructure. Then it's simple. The data is basically uploaded to the desired AWS service. So for example, Redshift, S3, Dynamo, and in this case, well, it's EMRFS. You can also have your application that is running in AWS that needs to store and encrypt data using your keys. And if you want to run your own key management service, you still need to provide that key to the AWS running application. So you do need access back to your data center if you have a key management service there. Or you can also put that key management structure on, for example, EC2 and simply replicate that scenario in that infrastructure. But you still need to maintain and manage all the heavy lifting and the access between the application and the encryption service. And again, the key item here and the sort of the biggest challenge is managing the access. So looking a little bit on how you can do server-side encryption instead. So in this case, we're going to look at S3 server-side encryption, but still use the customer-provided keys. So we're still going to use a key that is not stored on AWS. So what happens is that you take your customer-provided key together with your data and upload it to the S3 web service over, of course, HTTPS and TLS encryption. That customer-provided key, or S3 will then take the customer-provided key, encrypt the plain text data into encrypted data, store the encrypted data on the S3 storage fleet, and then delete the key. So when you use customer-provided keys, S3 will never store that key in the service itself. And that also means that when you need to access that data, you must write your client libraries to provide that same encryption key every time you access, both for uploads and for downloads. So you cannot upload the data and have S3 decrypted without providing that key. There are ways that you can sort of simplify for people doing wrong. You can use, for example, an S3 bucket policy or an IAM policy to ensure that when people try to do a put or a get, that they also have the option of key encryption and S3 encryption in the GET request. So you can force users to use encryption, and you can also enforce them, say that I want you or I require that you use SSE-C, so client-side encryption libraries. But the important thing here is that if you use this method, whatever application needs to consume that data must provide that key, and you must have a way to provide your application with that key so they can use it in the request. The managed option we want to discuss is Key Management Service and KMS. How many people have started using KMS? How many people use KMS outside of standard managed service like EBS? So how many people use it to encrypt like secrets and things like that? It's a couple of people. Awesome. So KMS is a managed service that simplifies creation, control, rotation, deletion, and most of the encryption keys, and use of the encryption keys in your application. I highly recommend, if you haven't looked at it, take a look at it. If you have developers that are using any kind of key management service or trying to encrypt data, secrets, whatever it could be, take a look at KMS. It's really easy to use. KMS is integrated with a lot of the AWS server-side encryptions. So for example, S3, EBS, RDS, Aurora, Redshift, Workmail. The list is long and continues growing. So it is already there for a lot of services for your usage. It's also integrated with a lot of the client-side encryption. So for example, the AWS SDKs, S3 encryption client, EMRFS, and also the DynamoDB encryption client. And one of the most important things, actually, it is integrated with Cloud Trail. So you get the auditable log of every key usage, so you can use for regulatory and compliance activities. So anytime you use a KMS key, that information is logged, so you can go back and see that. And KMS is available in all commercial regions except China. A quick note, when you go to the KMS management console, it will be under the IAM console, so it doesn't have its own main console. So when you go to the IAM console, you're going to see two different kinds of keys. These are the KMS master keys. The top ones you see there are keys that are created by you because you need to use it in a specific service. So you can either use it, for example, in your own applications, or you can integrate it with an existing service like, for example, EBS, like S3, and you can specify a unique key for different use cases. The bottom services that have a yellow icon are service-created keys. So they're still master keys running your account, but they're created by, for example, EBS, S3. And that happens when you say that I want to use KMS together with EBS, and you don't care if everyone is using the same key, you just want a master key. And the master keys are owned by you, so they're in your account. And we're going to talk a little bit more about the key access. But those are the cases where you simply say that I want to use KMS, make it easy, simple, create it automatically. The top ones are when you want to use them in your own applications, or when you want to use, for example, let's say you have multiple different EBS volumes that you want to ensure that they have different types of master keys. So you can individually assign usage and also revoke those keys. It could be, for example, if you have multiple customers and they want control over their own keys, you can actually issue control to the keys to a different account. A quick overview, as I mentioned, KMS is already integrated with a lot of services, making it even easier to use. We have, for example, on the storage side, EBS, S3, Snowball. Good to know on the enterprise apps, we have Workmail and Workspaces. You can also use it with the developer tools like AWS Code Commit and management of Cloud Trail. So Cloud Trail logs will automatically be encrypted when they're stored in the service. Important to know, they will always be encrypted. But you also have the option of choosing if you want to use a dedicated KMS key to store those logs. And also with Elastic Transcode and Simple Email Services and AWS IoT. A quick slide on how the clients and AWS services typically integrate. So the KMS integration is done through a two-tier hierarchy using an envelope encryption. So all encryption will be using envelope encryption. So you will have a unique key, excuse me, a unique data key that encrypts the actual data, and a KMS master key that will encrypt the data key. So if you want to issue a key that you can use in your own applications, for example, you can issue a data encryption key, and simply have the KMS service handle the master key. Each master key can create multiple and unlimited data encryption keys. So that also limits the risk of compromised data keys. Because they are encrypted with the master key, and also because you have a much smaller scope that they're being used on. That also gives you better performance when you're encrypting a large number of data and large volumes, since you're using multiple different data encryption keys instead of using a single master key. And it's also easier to manage a small number of master keys than having millions of data keys. So if you were to have to manage all those data encryption keys in the service, again, that would generate a lot of data keys. And the most important thing, it's centralized access and audit of key activity. So you can see anytime someone is decrypting data using the master key, or if someone is creating a new data encryption key based on an existing master key. And we'll show you a log to see exactly how that looks also. So you are in full control of how your KMS keys are used and by whom. So a couple of use case example here is, for example, you want to allow someone to only have a key that is only used for encryption and decryption by a specific user or a role in this account. And remember that the KMS can be used cross-account access. So if you want to say that this user is the only one that can use this key, but he has full access to that key and can do both encryption, decryption, and create data encryption keys, set up a simple IAM policy allowing that user that kind of access. You can also say that I want to have this application to only be able to encrypt the data, and then another application to decrypt the data. And this can also be applied for multiple other cases. So if you imagine that you have some sort of secret that you want to store, or if you have sensitive data from, for example, a forensic tool, and you want to store that data, but you don't want that function to also be able to decrypt the data, and you don't want any other user except an auditing tool to be able to decrypt the data, you can simply set up different policies allowing, for example, the initial function, which could be a Lambda function, to be able to store the data in encrypted format, and you can have another, for example, dashboard tool that is the only one that can decrypt the data. So make sure you limit the scope of what each user can do using IAM. Or you can, for example, say that you can only be used to decrypt the data if the service is available and if you provide additional parameters when you pass the call to the KMS service. This also applies for the management side. So you can say, for example, that this administrator only have access to these two keys and none others. So you can delegate both within your account and to external accounts. So if you have, for example, a customer that of yours that need access to their own key, so they want to be able to, for example, revoke that key and disable that key, thus preventing access to their data, you can actually issue external permissions as well. And all of this is done by integrating the service with identity and access management, so IAM. So make sure you limit the access to those keys, so you only have access to what you need to do. If that is, for example, decrypt or encrypt, again, limit the scope. It also has an automatic rotation feature, so you can set up an annual key rotation for the KMS keys. Excuse me, and you can do that on a key basis and say that I want to allow the service to rotate this. The way that happens is that when that rotation happens, the service will create a new master key using the same alias. So an alias is an alias that you can assign the key to make it easier when you integrate with your applications. So instead of giving it the full key ID, which is a very long string, you can simply say that this is data encryption key 1, or this is data encryption key 2. So the new key will use the same alias, and every new request coming into the service will use this new key. But any data that has already been encrypted with the old keys will still use the old key, and we will simply store a version of the key. So if you need to access older data that has already been encrypted, it's going to automatically use the old key instead. You don't need to do anything. You simply point to the alias, and it will still evaluate that you have permission to it, and simply use the right version of the key to decrypt the data. So if you, for example, pull data out and then re-encrypt it, it will automatically use the new key. But you don't need to sort of rotate all your data to use the new key on a given date. So that will happen automatically in the background once you start using and basically start storing new information. Looking at the auditability, like I mentioned, KMS stores every access in Cloud Trail. And I'm not going to ask, but I'm hoping that every arm goes up if I ask who's using Cloud Trail. And that's what I think, at least. So the way it looks in Cloud Trail is that you have an event, what happened. So in this case, it's decrypting. So it used the KMS API to decrypt data. We can see when that happened. Oops, there we go. What request parameters. So for example, here's the key ID. And this could be an alias as well when you actually make the call. But this is the key ID that was accessed. What was it trying to decrypt? So in this case, we actually was trying to decrypt a EBS volume. Where was this made from? And most importantly, who did this call? So once you have this information, you can also set up, for example, different types of logging. You can set up alerting. So if you see a key being used for a resource that you did not know it was used for, or if someone is trying to use a key on multiple different volumes or resources that it's not supposed to do, you can simply set up alerting either using Cloud Trail and CloudWatch, or you can also set up, for example, a CloudWatch event rule to look for certain patterns and certain APIs with certain information. But important to know that everything is available in the Cloud Trail, and you simply need to know what you want to look for and where you consider sensitive information. So for example, if you have a customer and you know that no one should access this key, set up an alert if someone is accessing that key to decrypt data. So looking at the assurances that we mentioned earlier, why should you trust AWS with your keys? Well, a couple of items. So first of all, your plaintext keys are never stored in non-volatile memory. This is also something that get asked frequently. There are no tools to access your physical key material. We don't have the tools for it. You control fully who has permissions to your keys using IAM. You control both usage and administrative access. And these are handled as two separate IAM policies. There's also separation of duties between the system that use the master keys and the ones that use the data keys. And you can find evidence of every KMS call in Cloud Trail, so you can monitor who's using the keys and who's trying to access it. So in a lot of cases, you are going to access the keys without you taking that option to do that. And that's, for example, if you're using KMS to encrypt EBS volumes. The EBS, as we saw in the login example, is actually the EBS volume that is trying to decrypt the key. The user is still the one that is calling it, but through that service. So they might not know that they're trying to use a KMS key, but they are doing it through a separate service. And also, we do have third-party evidence of these type of controls. So for example, our SOC reports, we have the PCI DSS report, and you can go to the compliance packages and request them. You can go to the AWS compliance page to see all the controls that we have in place. So again, looking at a little bit on the ubiquitous encryption. So we have encryption in transit from the services, so ELB to the AWS service, in this case EC2, back to encryption in transit to the different storage services like S3, EBS, RDS. We have data encryption at rest in these services natively, and we have auditing and fully managed keys in KMS that you can restrict the access to the different keys yourself. So you own the restricted access, you own the control of the access, and actually one of the most important things, it's fully auditable. So every usage is logged in the Cloud Trail log. Pricing for KMS, it's $1 per key version per month, and you pay 3 cents per 10,000 API requests. You do have 20,000 free requests per month through the free tier. And if you're using GovCloud, it's 4 cents per 10,000 API requests. There are a number of alternatives to KMS. So you can use, for example, CloudHSM. You can use a partner solution, or you can build it yourself. A couple of quick notes on HSM. You do receive dedicated access to a CloudHSM module or to an HSM appliance. They are located in the AWS data center. They are managed and monitored by AWS, but they are managed and deployed by you as the AWS account holder. The most important thing is also that they are inside the Amazon VPC, which means that they're isolated for the rest of the network. And they're based on a SafeNet Luna SAHSM appliance. But keep in mind, they are part of the VPC. So if you need access for your application, you can isolate that in an isolated network. They're available in 8 regions worldwide. They do follow, and they're included in our PCI DSS and our SOC 1 compliance package. They're also FIPS 140-2 level 2, so they're maintained by Jamalt and SafeNet. And a couple of use cases. For example, you might want to use it with either Redshift or RDS for Oracle. You can also integrate it with third-party software, or you can write your own application to use the key management. Another quick example, using CloudHSM to do EBS volume encryption. So this is when you don't want to use KMS to do direct volume encryption with KMS. In this case, it's using the SafeNet Protect V and Virtual Key Secure, and then using CloudHSM to store the master key. Keep in mind, when you do volume encryption, is that you enable that before you start storing data. So you don't go in and try and basically enable encryption after. So from a compliance perspective, you should not store sensitive data until you have the volume encrypted. Pricing for CloudHSM, it's when you provision it, there's a $5,000 one-time charge, and then it's a $1.88 per hour after you have it set up. And the hourly rates do vary by region, so make sure you go into the CloudHSM tool and see the pricing. Essentially, you can go down to as low as $21,500 for 1 year, and then $16,500 for the subsequent years. One thing to keep in mind on CloudHSM, if you do need HA, which you should have, that you do need 2 boxes or 2 appliances and set up the HA between there and high availability and replication. Requests are not billed, so it's not a per API call service. It's limited by the device capacity. Quick comparison with HSM, if you do have, for example, FIPS 140-2 or common criteria, CloudHSM do meet those regulations. You also have full access to the keys, which you do in KMS as well. It does require that you write your own software to it or use a software that has support for an HSM box. We do have some services that have direct access, direct integration with it, so Redshift and RDS for Oracle. With KMS, highly available and durable key storage, you don't have to worry anything about availability, about setting up HA or anything like that. That is handled by the KMS service itself. You can also use a partner network. So if you go into a partner service, so if you go into the AWS Marketplace, search for HSM, and you can find a number of partners that are available there and partner services. And they are paid by the hour. So you go in and subscribe based on the resource type you want. There's a fixed price by the hour that you simply use. So if you need something for a short amount of time, it might be a valuable option as well. And again, as we saw earlier, if you want to do key, you can also do your own do-it-yourself key management service. We talked about that earlier. Quick comparison, and the piece that I want to point out here is 2 things. Integration with AWS services. Using KMS, you have very good integration with all the different services. If you're using any other service, you have limited, or you might have to build the integration yourself. Also on the responsibility for performance and scale. With KMS, we are responsible for making sure that you have the resources that you need and the availability, versus you have to build that yourself. Looking a little bit on the S3 access and control and data resilience. So with S3 access control, we have basically a number of different policies, method of doing that. So we have our IAM policies to control which APIs can access the service. You can also set up a bucket policy, which is more of a resource-based policy, where you want to do, for example, cross-account access to your S3 buckets. And this includes all the S3 actions. You also have ACLs, which is also, again, resource-based policies on an object level, where you can go in on each individual object to set a ACL policy. Or you can also set a bucket level policy for log delivery. We also have logging, so S3 access logs, and also Cloud Trail integration. So anytime you do API calls against S3, that will be logged in Cloud Trail. When you access the files, so if you, for example, open up files for integration with your web services, those are accessed and logged through S3 access logs. Make sure you enable that to keep track of who is getting what. There's a couple of tricks you can do on the edge protection. So let's say that you want to limit access to your S3 bucket to only your own services running inside the VPC. Instead of setting up so you're using only IAM policies to decide who can access it, you can also set up a policy saying that if you don't connect through this VPC endpoint, I will not allow access. One benefit here is that deny will always win. So in IAM and our policies, any deny will always win. It doesn't matter if you have 10 other allows. There is no setting saying that, but I really, really want to access. Deny will always win over that. So in this case, you can say that unless you're coming from this VPC endpoint, I will not give you access even if you have the permissions to do so. Another typical and very common scenario is when you have S3 as the origin for CloudFront distribution. What you want to do is make sure is that only the CloudFront distribution can actually access that S3 bucket. You don't want to allow access outside of that, outside of CloudFront. And in this case, you can use something called origin identity, so CloudFront origin identity, and say that I allow access to the data only if you have this canonical user in the principal field. And then that origin access identity, you simply get from the CloudFront distribution and add here. And that way you know that no users are going outside of the caching layer, where you might have, for example, IP restriction filters, you might have WAF features, or other type of security implementations. You can also have an IP ban list, for example, or blacklist that you maintain through the WAF service. So make sure that you limit usage from CloudFront, and also if you have something that you only want to access from your EC2 instances, set up a VPC endpoint for S3. Another type of data resilience access or data resilience is replication, so cross-region replication. So let's say you want to make sure that your data is stored from a compliance perspective with a great distance between the data storage. Cross-region replication is a really good way of saying that anytime you store a file in this S3 bucket, automatically make a copy in another region. It is also a really good way to distribute. So if you have regional customers, so let's say you have your main data bucket in US West, but you also want to have access from, for example, Europe, you can easily set up an S3 regional replication over to that EU West bucket. Another good use case is if you have multiple accounts, so if you want to limit the blast radius, is that if you have a backup copy, let's say you were to have a compromise in your account, if you have a backup copy of everything, it will be stored in a separate account. A couple of details here. The way cross-region replication works is that it's going to do a head operation and look to see that A, it has not been replicated before. If it has been replicated before, it will not automatically make a new copy of it. And also, it will not copy existing objects. So if you have existing objects, you need to use, for example, S3 copy and copy those over first. We will also verify, for example, ACL so that you are actually the owner of the bucket that you're trying to set up a replication from, and that you have access to the bucket you're trying to replicate to. We will also not replicate objects that are KMS encrypted, and the reason for that is KMS is a region feature service, so it's region-based. So the KMS keys will not leave that region. So if you're trying to replicate to another S3 region at the moment, you cannot use KMS integration. The cost for that is usual storage cost and transfer cost. You can also set it up to replicate into, for example, a different storage zone, so standard IA or Amazon Glacier. Objects that are created by lifecycle policies are not replicated. So it's only objects that are created by you as a user. Same thing, objects that are put in an S3 bucket using the replication service will not replicate to another hop. So you cannot set up a multi-hop scenario either. It's a one-to-one replication. You can, of course, do bidirectional replication. So if anyone changes and adds a file in one bucket, it will replicate over to bucket A. If someone adds a file in bucket A, it will replicate to bucket B. But you cannot have it to replicate to bucket C automatically. Delete operations will also be replicated. So the marker will be replicated over if you just do a delete. But if you do a delete on a specific version, the marker will not be replicated. Moving on to the database security, so we do have a number of commercial database solutions, so MySQL, Postgres, SQL Server, Oracle, and MariaDB. We also have our database services, Amazon DynamoDB, Redshift, and Aurora. Couple of notes, why would you use Amazon database solution? Well, you are responsible for the schema designs, query constructs, and query optimization, but we will take care of high availability, backup, isolation, compliance, scaling, all those other items. So again, let us do the heavy lifting, and you can focus on adapting it for your service. You can also use multi-AC deployments to make sure that the data is replicated over to a separate availability zone. in case of failure on that database. And you can use cross-region replication for snapshots. So again, if you want to set up to a different region for backup purposes, or you want to have, for example, a warm standby, or simply if you want to start migrating your data to a different region, you can actually use the cross-region snapshot replication. Or snapshot copy, sorry. And a quick overview of the services that do have encryption address. So we have server-side encryption with KMS, the RDS family, including Amazon Aurora and Amazon Redshift. You can also use server-side encryption with CloudHSM, as we mentioned earlier, with, for example, Redshift, or if you want to use RDS or Microsoft and use the TDE protocol. And lastly, you have client-side encryption with the DynamoDB encryption client. And you can integrate that with the KMS service. Quick mention on IAM and Cloud Trail. Make sure that you follow separation of duties on any kind of API permission and IAM policies. Don't give ***. Give people the access they need. Use roles, for example, to limit the scope. If it's multi-accounts that you need to set up for, use a Zoom role feature. But don't give everyone the full permission to do whatever they want to. You can also use, for example, tags as a resource-based permission and use a constraint based on tags and make sure that you integrate with and use Cloud Trail. Quick show here on Cloud Trail. Anytime you make an API call, that record will be tracked in Cloud Trail. Cloud Trail has a lot of integration with other services, so you can use, for example, CloudWatch events to trigger on Cloud Trail. We're also going to have Kapil is going to show a couple of examples on how they use, for example, Cloud Trail logs to detect changes and also take actions on those changes. And lastly, a quick overview of a couple of different tracking and detection tools you have. So for tracking, we have AWS config and config rules. Definitely recommend you look up if you need to carry a trace of all the changes that are happening in your account and be able to do a timeline view when something changed and what changed on those resources. You also have CloudWatch events to do instant and near real-time actions on changes being done in your account. CloudWatch event and Cloud Trail config rules are, if you haven't looked them up, they're really, really awesome services for tracking changes and for taking actions. So anytime you have any kind of incident response remediation features you need to implement, use those services. Cloud Trail, no-brainer, always enable Cloud Trail. Always enable Cloud Trail in all regions. Even if you're not using a region, enable Cloud Trail there. Because if I were to look in an account and saying that, I wonder what I can do, I will not pick the region where you have Cloud Trail enabled. I will pick the one that you don't have Cloud Trail enabled. So make sure you use Cloud Trail in all regions. You can enable that through a single call now, where you can say that I want to enable Cloud Trail with these parameters, do it in all regions. When you get that option, say yes. Amazon Inspector, take a look at that. If you haven't gone to Amazon Inspector sessions today, definitely go down to the floor and ask about Amazon Inspector for host-based security and host-based detection security. Coordination, you can use, for example, simple workflow, or you can build your own using CloudWatch events and Lambda functions for the execution engine. And on the security side, make sure you use MFA on your IAM policies. Everyone should be using MFA. Also make sure that you enable MFA on the user, but also in the actual policy. Anytime you use a high privileged API, so for example, anytime you delete resources or create certain resources, make sure you use MFA for those. And track and logging, CloudWatch logs, DynamoDB. DynamoDB is a really good tool for maintaining state of what is going on. So if you're using, for example, a Lambda function to track changes that are being executed through CloudWatch events, use Dynamo to track information. So for example, if you want to see who did this, okay, user A, okay, store that information in Dynamo. I'm going to encrypt it first. If that user has done it before, you might want to consider taking action on it. But store that information so you can do repeated patterns. And lastly, on the alerting side, Amazon Simple Notification Service. Really easy way to integrate and send that alerts. You can even integrate it directly through CloudWatch events. So with that, I would like to hand over to Kapil to hear a little bit about Cloud Custodian and how they handle data protection.
Thank you. Hello. Mic test. At Capital One, we've been using Amazon Web Services to deliver innovative new applications for customers. Two of those recent apps that we debuted at South by Southwest last month were an Amazon Alexa Skills app where you can interact with your bank account simply through your voice, as well as our developer exchange portal where app developers can integrate with our APIs. Data protection is near and dear to us. We operate in a heavily regulated industry, and the integrity of our assets is paramount. To do so, we use a mix of tools and techniques, including built-in AWS features, custom tools, and third-party solutions partners. First, whenever possible, we try to limit a developer's access to be able to create non-compliant resources through IAM policies. For more fine-grained sharing between accounts, we rely on resource-level permissions and policies. But IAM can't solve everything. And to fill the gaps, we use a mix of homegrown tools that utilize Amazon's CloudWatch events for real-time remediation, which we'll talk about in more detail in a minute. On the periodic side, we do whole fleet analysis with a mix of vendor tools and homegrown to guide automated and manual remediation. Amazon CloudWatch Events is a relatively new service from Amazon that offers unparalleled infrastructure management capabilities. Previously, it was common for tools to poll the API on a periodic basis, even when there was no change to any underlying resources, just so they could attempt to detect a change. With CloudWatch Events, we can simply subscribe to the events of interest and be notified as changes happen. Moreover, this service has full coverage over Amazon's APIs via its integration with Cloud Trail. Now, we can easily enforce our organizational policies in real time on top of the Amazon APIs. I caught a tool in one of our accounts doing over 1 million API calls in a single day, just polling for changes. And I think the reality is we have to stop doing that. If you wanted to do real-time policy enforcement in AWS, the game has changed. So coming from the data center and moving to the cloud offers us opportunities to automate infrastructure compliance with API usage. It's very natural to use those APIs to create a single one-off script for a particular policy, but we have dozens of policies at the moment and more on the horizon. We don't want to end up in a place where we have hundreds of independent scripts across many accounts developed, deployed, and operated independently. It becomes really unwieldy to get a holistic view of what's actually happening in our infrastructure. But if we look a little bit deeper, we can find the patterns that all these tools are doing. Namely, in a nutshell, that they are querying the API, using the API to query resources, filter those resources, and then take actions on them and report the results. So what if we could just have a single tool that encompasses those patterns? I'm proud to announce a new open source project from Capital One, Cloud Custodian. It's a rules engine with a YAML DSL that automatically provisions Lambdas and integrates with CloudWatch events. On the right-hand side, there's an example policy here of basically subscribing to any time an RDS database is created, and then automatically filtering to see if it's encrypted and if it's publicly available. And if either of those two things are true, nuke it. Cloud Custodian is open source today on our public GitHub. And what's nice about this is that we can use the same policy in this real-time prevent mode with CloudWatch events, or we can use it sort of on a whole fleet basis. The only real delta is that mode section. If I take that away, then that same policy runs isomorphically on the whole fleet doing a query. So some of the philosophy behind it. So for each resource type in AWS, we come up with a vocabulary of reusable filters and actions that you can use. And you can then string those together to construct policy statements. So, for example, resize an instance that matches a CloudWatch filter that says that it's not being used fully. Take off hours at night based on a time-based filter. But coming back to data protection, since that's our talk today. So on the left-hand side, I've got two S3 policies here. One is a real-time throw a encryption required resource policy on the bucket so that no unencrypted objects can ever be written to that bucket. And on the right-hand side, we've got sort of a more a traditional poll-based policy, which will actually fully scan through the bucket. One of the caveats with real-time writes and requiring encryption on bucket policies is some of the AWS logging services actually don't support encryption, and you will break them if you apply this policy to them, to buckets they're using. But this, if we run this from the command line, this will actually go ahead and provision the Lambda, set up the CloudWatch rules events target, and operate by itself effectively. No servers to manage. The right-hand side actually will do a full scan of every key in a bucket and go ahead and encrypt it. And there's different options and parameters around the encrypt keys action to support KMS keys as well as customer supplied keys. So for EC2, on the left-hand side, again, we've got a real-time policy using CloudWatch events. It's subscribed to any time any new instances are being run that we verify that they have encrypted volumes. If they don't, then we just terminate them. On the right-hand side, we have basically doing the same thing against instances that are not in autoscale groups on the right-hand side, we actually have something a little bit more interesting. We're actually going to remediate against an existing fleet of instances. So say you've got a bunch of, you want to introduce Cloud Custodian into your account, you've got a bunch of stuff that potentially needs to get fixed already. So you can actually use it to remediate part of your extant fleet, and then it'll do the dance of stopping the instance, taking a snapshot, encrypting the snapshot, patching the instance, starting the instance again for you. So in summary, you have lots of options.
There we go. Is it on? So yeah, you do have a lot of different options to implement data controls that meet your business needs. I would highly recommend that you go out and check out both Cloud Custodian. We have a number of different open source projects. So for example, the S2N library. We recently launched on AWS config rules. We launched a open source project as well. So if you search for AWS Labs and config rules repository, it has a number of predefined config rules that you can implement as well. So use these different available resources to implement the controls that you need to make sure that your account is in a good state. Take advantage of the managed services. If you do have, if the service is available as a managed service and you don't have any kind of rules or regulations that prevent you use it. Let us do the heavy lifting, and you can focus on the business need that you have. And also protect the data, but make sure that you track and detect it. Use the services available for tracking, for example, Cloud Trail, CloudWatch logs. Use DynamoDB to maintain, for example, state. Make sure that you encrypt sensitive data before you store it. So if you have something that needs storing data in, for example, Dynamo, use either the client-side library for DynamoDB, or if you just want to use it from a Lambda function, it's a simple API call to encrypt a single key or a single secret. So make sure you track, protect, and detect any kind of changes that you have. With that, thank you for coming. Again, make sure you fill out the survey. If you have any questions, we got about 5 minutes. Feel free to shout them out in the mic, or if you want to come up here and talk. Mic is right there.